Okay, this is question 6 in the vectors homework, and this is about a football player who kicks a ball from the point A with position vector 2i plus j on a horizontal football field. The motion of the ball is modelled as that of a particle moving horizontally with constant velocity 5i plus 8j meters a second to the minus 1. So we need to find the speed of the ball and the position vector of the ball after t seconds. So first part of the question here. Second part of the question has at the point B of the field position vector 10i plus 7j, and find the time when the ball is due north of this. So when the ball is due north, the I components are going to be equal. The I component of this position vector and the I component here. And then at time t equals 0, another player runs due north from B and intersects with the ball, and we need to find the velocity that that player has run. Okay, so let's get the first part done and then we'll come back onto the second part. So we've got something looking like this. We've got the initial position vector, which is 2i plus j, and we've got the velocity vector over here, 5i plus 8j. And so first of all, we want to get the speed as part A. So speed is just going to be the magnitude of the velocity vector. So speed is going to be 5 squared plus 8 squared, and the square root of all of that. So we're going along 5, we're going up 8, and that gives us 25 plus 64, square root of all of that, which when we stick that in the calculator gives us 9.43 meters second to the minus 1. Okay, well then in part B we're asked to find the position vector. Okay, so basically the position vector is going to be any vector from the origin, which is effectively going to be this initial position vector at t equals 0 plus the component of the vector due to the velocity. So to go from there to there, it's the same as going from there to there, and then from there to there. So it's the initial vector 2i plus j plus this component along here, which is 5i plus 8j times time. And again, expand the bracket out here, then bring the i's and the j components together. So we've got 2 plus 5t times I plus j plus 1 plus 8t times j. Okay, and the next part of the question said the point B on the field has position vector 10i plus 7j. Find the time when the ball is due north of B. So 10i plus 7j, let's just say for example, let's say over here somewhere, not to scale, but just conceptually, 10i plus 7j, this is B, and we want the time when the ball is due north of this, so it's when the ball is immediately above this, and when the ball is immediately above B, then the value of the I component here, or the I coefficient, must be equal to 10i. So in part C, we've got 2 plus 5t has got to be equal to 10, which means that 5t is equal to 8, which means that t is equal to 1.6 seconds. Okay, and then the next part of the question, so we've got that at time t equals 0, another player starts running due north from B and moves with constant speed v. Given that he intersects the ball, find the value of v, his speed. So essentially what we've got is a player starting here at B, running due north and intersecting the ball at this point up here. So really all we're trying to do is find this distance along here, and then the speed is the distance divided by time. So we know that t is equal to 1.6, so essentially what we need to do now is find the j component when t is equal to 1.6, and that tells us basically how far vertically this ball has moved up the pitch. So part D, at t equals 1.6, the j component is going to be equal to 1 plus 8 times 1.6, which gets me, in fact if I do the 1.6 as keep it as 8 over 5, easier to see what's happening, and that gets me 69 divided by 5. Okay, so the distance, this distance along here is going to be the 69 divided by 5 minus the initial 7 along here. So the distance that the player runs is 69 divided by 5 minus 7. And 7 is 35 divided by 5. 69 minus 35 is 34 divided by 5, and that gets me 6.8 seconds. 6.8 meters rather, sorry. Okay, so the speed that he must run is his distance divided by time. Again, the question is asking for speed rather than velocity, but in this case, because he's just running purely in the y direction, then we don't need to bother about Pythagoras at all. But the distance now is the 6.8 meters that we've calculated already, divided by the time of 1.6 seconds, gives me a speed of 4.25 meters a second to the minus 1. Okay, the final part of the question says, state one physical factor other than air resistance which would be needed in the refinement of the model of the ball's motion to make the model more realistic. Well, other than air resistance, it could be something like the wind direction, it could be any spin on the ball, and that's probably about it. So it's just a bit of imagination here to try and fill out the last part of the question. Okay.